30%. That is the average energy waste in commercial buildings according to Energy Star. To address this problem and reach higher levels of energy efficiency, building managers and operators implement energy management systems. But there is still a lot of confusion about this topic that I hope I can help clarify. In this video, we'll go over what is an EMS, why to implement an EMS, what are the benefits of having an energy management system, how to implement an energy management system, and what to track in an EMS. So let's get started. A building energy management system, EMS or BEMS, is an interface that allows building operators to monitor and supervise energy-related metrics in a building, such as power demand, power consumption, and energy efficiency ratios. An EMS normally tracks energy data of the most energy-intensive equipment and systems in a building, which are typically the HVAC system, the lighting system, and the water heating system. On average, these three systems combined account for almost 70% of the total energy consumption in commercial buildings according to Energy Information Administration, or EIA. So it makes sense to supervise these three systems very closely, as they make up for most of the energy costs that organizations incur in the form of power consumption. This is when implementing an EMS can come in handy. But first, I would like to clarify some terminology. Very often, the term EMS is confused or used interchangeably with other terms such as BIS and BMS. Although these terms are related to each other, they have their own distinctions and purposes that differentiate them from one another. I already made a video that explains the terms BMS and BIS. You can find them in the description of the video. The main takeaway is that an energy management system is implemented with the specific purpose of monitoring and supervising energy-related metrics in a building. It's important to get this clear because I've noticed that most buildings don't develop a complete EMS interface because they think they already have it, but they don't. In other words, the confusion between these three terms has over time diluted the real meaning of what a true EMS is, which is worth mentioning one more time. An interface for building operators to monitor and supervise energy-related metrics in a building. But now, why would you want to know energy-related metrics of your facilities? An EMS is implemented with three main objectives in mind: to improve building operators' visibility and awareness from a building energy consumption and efficiency standpoint, to help building operators to make informed decisions to eliminate possible energy waste sources and improve the overall building energy efficiency performance, and to discover and unlock energy savings opportunities that can positively impact the bottom line of the organization while contributing to decreased greenhouse gas emissions. Energy management systems track real-time energy performance data of equipment, systems, and overall facilities. This data is put together and presented in a user-friendly interface to the building operators, enabling higher levels of building supervision, awareness, and efficiency. For instance, one of the benefits of having an EMS interface is the capability of visualizing the power consumption pattern of the building. This is a very valuable and actionable data that operators can use to manage and adjust equipment operating schedules and set points to reduce power consumption and maximize energy savings. This building consumption pattern also enables another benefit that I call power pattern anomaly detection. Even though power consumption is a function of demand, there's a common pattern that can be identified, which allows building operators to predict and take measures to preemptively address possible failures and avoid unnecessary energy waste. Without real-time energy tracking, it's very difficult to front-run developing energy waste sources. It's a lack of an EMS that forces most buildings to follow a reactive approach when it comes to energy management. And every once in a while, building managers get shocked with a higher than expected power bills, affecting budgets and the bottom line of the organization. Another benefit of implementing an EMS is the capability for building operators to visualize the building power distribution by end use. In other words, the breakdown of the different systems' power consumption and demand in a building. This data provides building operators with information about the main drivers of energy consumption in the building, and therefore, where to dedicate the most effort optimizing. For instance, it's more likely to achieve higher savings opportunities optimizing the HVAC system and the lighting system than trying to optimize any other system in a building. So having an EMS provides the visibility to help building operators allocate efforts and resources more efficiently when looking to maximize energy savings. That brings us to another benefit of implementing an EMS, which is building power consumption optimization. This is the process of making building systems more efficient through optimization sequences and automated setbacks. There are many control optimization strategies that can dramatically improve the overall energy performance and efficiency of a building, more commonly applied to the HVAC and the lighting control system. Lastly, the final and most important of all the benefit of implementing an EMS, which is to unlock energy savings. Depending on the initial conditions of the facilities, energy savings in the range of 10 to 30% can be achieved through energy management and optimization strategies. These energy savings represent, in many cases, a significant amount of capital for organizations that want to improve their bottom line and grow, while simultaneously positively impacting the environment by reducing carbon dioxide and other greenhouse gas emissions. It's important to note that energy management and optimization strategies can be done without the need of implementing an EMS. I'm just saying that having an EMS will provide you with better visibility and quicker feedback on your building energy savings efforts, and will also help you keep those savings once generated. Now that we understand the value of an energy management system, it's time for implementation. For existing buildings, the most cost-effective path is leveraging the BMS and BIS infrastructure to build an EMS interface on top of it. Other technologies such as IoT devices can also help in the implementation process. In general, integrating equipment and devices such as power meters, frequency drives, switch gears, and transfer switches into the BMS infrastructure can provide all the data points necessary to build out the EMS interface for building operators to manage and evaluate the building energy performance in real time. On the other hand, for new construction buildings, the most recommended path is to add EMS specifications in the early phases of design into the construction documents with the help of EMS consultants and MEP engineers. This ensures that the building design is conceived with the objective of providing an energy management platform for future building operators. However, one important step we have to take before implementing an energy management system is to be clear about what we wish to track and supervise, as this will have a direct impact on the cost of implementation. Every data point can provide some level of visibility, but to make a cost-effective implementation, we should allocate resources where we can expect the higher return on investment. For simple analysis, I prefer to classify the energy management data into three main categories: building power data, building energy benchmarking data, and equipment efficiency data. The building power data is composed of the electric power factors that typically make up the building power bill, such as total building power consumption, building power demand, building peak demand, and building power factor. These are the factors that ultimately determine the cost of electricity for a building, depending on the building structure or plan with the utility company, which is also important to find out. This way, we know where to dedicate the most effort optimizing. Additionally, we can estimate building energy benchmarking data or performance factors such as energy utilization index and energy cost index. These are indexes that serve as a mechanism to measure the energy performance of a single building relative to other similar buildings. Even though we may need data to be archived for at least a year in order to estimate these indexes, we still can track a modified version of these indexes by calculating the real-time power demand per building square foot. This energy ratio can provide real-time energy performance comparison between multiple facilities. Lastly, but not less important, we should also track equipment efficiency data. As you may know, equipment manufacturers normally provide expected efficiency data on the equipment, so with the help of an EMS, we can track this data in real time, such as energy efficiency ratio for HVAC, energy factor for water heaters, and illumination power density for lighting systems. These data points can provide the real-time performance of the main drivers of power consumption in a building and help operators identify energy waste sources and inefficient systems that may need maintenance, repairs, or replacement. If we combine all this data into a friendly user interface, we can visualize a clear picture of the building, equipment, and system's energy pattern and performance, forming what is a true building energy management system, which will allow building owners and operators to make informed decisions to optimize systems and eliminate energy waste sources, unlocking unprecedented savings in power consumption. I hope you found this video helpful. If you enjoyed it, please give it a like and consider subscribing to my channel. Thank you for watching and see you in the next one.